Alright, so let's welcome here. We're going to go talk about system applications. You're going to try to identify patterns, set up and solve system word problems. Now, going through the different pages here, because I've got this broken down by groups, just to kind of make things easier for you, and then we'll start mixing them in, and hopefully you'll be really well prepared before you take the next test. So, first here's your number problems, and there's a previous video that goes over this, but we talk about sum and difference, x plus y equals something, x minus y equals something else. Make sure you read those carefully. Setup should be easy for those. Perimeter, 2L plus 2W equals something, and then the second equation has been L is equal to, or W is equal to, the length is, the width is, and whatever it may be equal to. But keep in mind the word is less than and more than, because what those mean, those will be very critical. Okay? Money problems, x plus y equals something, x plus y equals something else. You know, those should be pretty easy. And then we get to mixture. Now, this is very important. Mixture, you have a total equation. X plus y equals sum total. And then you have a mix equation. Something times x plus something times y equals something times something else. I know that's a lot of somethings, but anyways, but it's always going to be x plus y. So let's look what I mean by there. Okay, so look at number one. On number one, you're talking about, it talks about candy worth $1.05 a pound. So I'm looking at your sheets here from the thingamabobby, those pages. Okay, it says candy worth $1.05 a pound is mixed with candy worth $1.35 a pound to produce a mixture worth $1.17 a pound. How many pounds of each candy were used to make 30 pounds of the mixture? Okay, so if I read this correctly, the first thing they mentioned was candy worth a certain amount, $1.05. And then the second one they mentioned was candy worth $1.35. So I'm saying, and then there was 30 pounds made. So my first equation goes like this: x plus y, just x plus y. It won't change. X plus y equals, how many pounds of candy are we buying here? 30 pounds. Which, yes, I know this seems like a perfect day for me to be talking about candy. Anyways, then here's your mixed equation. This is where the other amounts come in. So like the $1.05, x was $1.05 candy. I'm mixing in the $1.35 candy, and I'm going to get a total of 30 pounds times the $1.17 amount. So notice how those three amounts kind of work themselves in. And you can actually type it in like this with a 1 and a 1. 1, like your matrix would look like this: 1, 130, 105, 135, and you can type in 30 times 117, and then press enter, and you'll have your answer. So kind of go with it like that. Okay, and that's all you got to do. Look at the next one. The next one talks about peanuts. Peanuts worth $2.25 a pound or mixed with cashews worth $3.25 a pound produce a mixture worth $2.65 a pound. How many pounds of each kind of nuts were used to produce 35 pounds of the mixture? Okay, so x plus y, that's my first, equals how much did I make? I made 35 pounds. Then the peanuts are worth $2.25 a pound. So notice how I'm kind of writing this. Notice how I've got this set up to where I can put some number in front of the x plus some number in front of the y. It's like I recopied the total equation, but I'm just going to put some extra numbers there. Peanuts were worth $2.25. Cashews were worth $3.65. I'm sorry, $3.25. And the mixture was worth $2.65. Notice low, high, middle. That's another thing. Okay? And then you could type that in and you would have your answer. So we'll talk about those more if you need help, but that's really all it is. There's a total mixture, x plus y. The total will never have anything in front of it. X plus y equals whatever, what you're making. And then something times x plus something times y equals something times the total. Okay? Now let's look at motion. Motion problems talk about usually something going downstream or with the wind, because like if you're going, like let's say you're going down a river, you're going downstream, the water is helping you go faster. Okay, but if you're going upstream, you're working against it. So we have an x plus y because that adds to our speed, and then we have an x minus y because that takes away from our speed. Now keep in mind, x is like your speed or the person we're talking about, and y will be the water or the wind. And time should always go in front. Notice here I have this set up, x plus y in parentheses, time, how long it took, and distance, how far I got. Over here I have time and distance also. And again, downstream will be our x plus y equation, upstream will be our x minus. Okay, so first equation, I'm looking at number 1 in Grape Creek, Jim can row 30 kilometers downstream in 3 hours, or he can row 18 kilometers in the same amount of time. Find the rate at which he rows in still water and the rate of the current. Okay, so notice here I've already got this set up, x plus y, x minus y. Now it says he can go downstream 30 kilometers in 3 hours. There's 30 kilometers, 3 hours. In the same amount of time, he can go upstream 18 kilometers. So same amount of time, notice 3 and 3. Distribute, and then you're ready to solve. 3x plus 3y equals 30. 3x minus 3y equals 18. And then solve it. So they're that easy to set up. The hardest part about these is supposed to be setting up. But guys, again, the patterns are there. They don't change. Let's look at the next one. Number 2. Prairie Dog Creek, Gary, I don't know, can row 60 kilometers downstream in 4 hours, or she can row 36 kilometers upstream in the same amount of time. Again, notice how I've already got x plus y, x minus y set up. Find the rate she rows in still water and the rate of the current. Okay, it says here she can go 60 kilometers downstream in 4 hours. So notice here, distance, time. In the same amount of time, she can go 36 kilometers upstream. Okay, so notice distance and time. And then you distribute, and then you're ready to solve. So a lot of this is real easy to do. It's just a matter of practicing. Hopefully this will help you get ready for those last couple of pages, and you can have all this done before the end of the next day. Anyways, that's it for today. Thank you so much. Thank you for taking the time to listen.